Greetings and welcome to another Dev Bootstrap screencast. In this screencast, we are going to show how you can test time-dependent Solidity functions in your smart contracts. Let's take a look at the example application now. So in this application, we have a time-dependent smart contract that basically has a couple of states where there is a started and an ended state in the contract. In this diagram, you can see here at the top in the green line here is a time t. As this moves from left to right, time is moving forward. And at various intervals, the smart contract state will change. So for example, if we come over to the left side here, I have a marker here, t now, which denotes when the contract was deployed. And at this very moment in time, the smart contract has a start of false and an end of false. And then as we move forward in time, as time progresses along this green line here, eventually we hit T start, which will then change the state of the contract so that the start is now true, but of course the end is still false. As we continue through time, we hit the T end time stamp, and at that point the contract is in a end state, and perhaps we might kill it, or we might disable some of its write properties and make it read-only, or whatever you want to do in your particular smart contract for that use case. Now, a typical use case for this would be crowd sale smart contracts for crowd sale of coins. So a timed crowd sale where you have an open and a close. That's typically what you might have in a crowd sale smart contract. And naturally what you want to do is have this logic, which is usually provided or usually implemented using OpenZeppelin's time smart contract for crowd sales. But the question therein lies, how do you test these types of functionality, right? And what you need to do is you need to do something as shown on the bottom here, which indicates the time line for testing. So down here at the bottom of my diagram, I've got an indicator here of testing before started state. So here, once we deploy the smart contract, we want to test the state and the behavior of that smart contract before the contract hits the start time, or let's say before, if it's a crowd sale, before the crowd sale opens. And then in order to make our test sufficient, because obviously it's not practical to wait for the start time to actually arrive, we want to time travel. We want to use some kind of time traveling functionality in our tests to move time forward, as shown here in this orange arrow down the bottom here. So we can use, and you'll see this in the example in a second, OpenZeppelin's time helper libraries to do this. So we essentially move time forward, which is essentially moving the block time forward in our testing blockchain to T start. And then once that has happened, we can start to test all of the during started state and before ended state behavior of our smart contract. And once we finish doing that, we move time forward again to the point where the timestamp is equal to t end, and then we can test all the after ended state behavior of our smart contract, which might be, as I mentioned earlier, that it's read-only, or certain functions are not available, or the contract is killed, whatever is needed in your implementation. So this overview here shows what we're going to build in our example application today. So let's head over to our code editor. Here I have prepared a very simple application where actually all I've done is I've just basically unboxed a simple truffle app. So actually I haven't even unboxed any app. I've basically run truffle in it. So I've initialized a truffle application, and I've done one thing, which I've added a few dependencies here, which I've already installed, just to save time in this video, really. So what I've installed here are OpenZeppelin packages that we will use for this project. So I've installed the CLI. I've installed a test environment because we're going to use the OpenZeppelin test environment for this example. We're not going to use the truffle test environment. And I'm going to use OpenZeppelin's test helpers. I find that the OpenZeppelin testing environment is actually pretty good, and their test helpers are very, very useful. And in today's video, of course, we're going to see how we can make use of their time manipulation of helpers for running our tests. So I'm going to run truffle create contract testing time. Testing time is the name of the smart contract that I want to create. So here is the contract, and I'm also going to create, using truffle, a migration, and I'm just going to call this testing underscore time. And that will be where our migration will live, which should appear in here. Right, there we go. So I'm going to start off with writing the smart contract, then I'm going to write the migration, and then I'm going to write the test, and then I'm going to demo that. So in our testing time, we want a start time and an end time. And the way time is represented in Solidity is by timestamps, and we need a uint 256 to represent that. So we have one for the start time, and we have a uint 256 for the end time. Okay. In our constructor, we want to set these two variables because we're going to set them during deployment of the smart contract. So we pass in start time, and we pass in our end time. So like so, okay. And then we can set our state variables, start time and end time, based on the two parameters passed in there. Okay, that's fantastic. And what I'm going to do now is I'm just going to keep this really simple. I'm going to have two functions, one that indicates if the smart contract has started, and one if the contract has ended. So we're going to create a function. I'm going to use this template, which is quite handy. So has started, and it is going to not actually take anything as a parameter, but it's going to return a Boolean, and that is going to be a return statement here. Return. And what do we want to return? What's our Boolean? Well, for has started, we want the time, the current time, to be greater than or equal to our start time. In other words, if we have a head over here, it's basically that the time t here is over here. It's moved past this marker here. It's moved past t start. So the way that we get current time in our smart contracts is to use block timestamp, block.timestamp. That is essentially giving us the current time of the EVM that's processing this smart contract at the time, or at execution time, at runtime. One other thing we need to do here is make this a public and view function. Now, we can add our second function, which is basically, actually, it's pretty much the same as this. So I'm just going to copy and paste this. And this is basically has ended. Okay, everything is the same, except we now want to be greater than or equal to the end time, and that's it. So these two functions now serve as our food, if you like, for testing out our functionality. So before we can test, we have to, of course, write our migration. So let's just quickly get that out of the way. So we have a const testing time is equal to artifacts require, and then a testing time, like so. And then we can use the handy deployer instance deploy function, and we can pass in testing time. And we need to pass in actually the start time, the end time. So if I just put in start time an end time here. Now this is something that we can set just above this. So I can start, I put start time is date.now, and we can have, say, an end time is equal to maybe start time plus I don't know. We just add 1,000 to that, right? It's fine for now. Okay, so let's compile. Actually, truffle compile and make sure that this is all running. Okay. So this is compiling. That's compiled. Okay, and let's see now. Let's see what we can do. So I think what we can do actually is we can write a test. So let's create a new file here for our test called testingtime.test.js. And in our testingtime.js, I'm going to just drop in a few things just quickly so that we can get the dependencies that we need. So here I'm bringing in the test environment. I'm bringing in test helpers. In particular, I'm bringing in the time test helper, which we'll be working with extensively in this. And I'm bringing in expect from the try framework, and I'm bringing in the contract itself that I want to test. So I'm going to start off with a describe block where I'm describing testing time. Essentially, I'm saying here I'm describing the testing time contract. And I'm going to set some variables at the top. I'm going to call testing time instances test TT. And I'm going to have a start time and an end time. So here I've just defined a few variables that we can use in our smart contract. Okay, now I've got the wrong parenthesis here. Okay. All right. So first thing we want to do is we want to deploy our contract. Okay, so if we go back here, we deploy the contract at T now, right? And we deploy the contract with a start and an end state of false. And this is actually, if you note, this is a validation if you were using Crowdsale smart contracts, where when you deploy your smart contract, you cannot deploy your smart contract after T start. So for example, what I mean by that is if you actually went ahead and tried to deploy your smart contract here, right, at that point, after T start, that would not be valid in a Crowdsale smart contract because the open time of your Crowdsale is after the current time, and that's not permitted. So we're going to always deploy, in our case as well, before the contract has started. And so we can have a before each block, and we can have a sync, because we're going to have some synchronous methods here running. And what we need to do is we need to set start time. This is where we can start using the time helper. So let's set start time equal to, we can use the time helper. So let's have a look. What methods do we have on this? And we have a bunch of methods, which we're going to look at some of them in a minute. But one we need now is to get the current time is latest. So we pull up latest, and but if you consider what I just mentioned about the contract needing to be deployed before the start time is hit, we should really add some time to our smart contract start time so that when we deploy it, there's still some time left before the state should actually change. And so we can add time to the start time. Now, one thing to note is that this is asynchronous, right? So we need to have an await here, and then we need to wrap this so that we wait for the latest time to come back before we call add. So we can add some time to that. And now we can use the duration function, and the duration function has a bunch of properties, days, hours, minutes, seconds, weeks, years, which we can use it to add some time. So I'm going to just add 1 hour to that. So basically, this now will set the start time to the current block time, essentially, and then add 1 hour to that. So we easily get a start time that's in the future from when we deploy the smart contract. I'm just going to copy this line, and I'm going to create an end time variable here, which is going to be the same, but I'm going to add 2 hours to it. Because obviously, again, in terms of validity and in terms of making sense for our tests, we need this to be after the start time. Of course, we could have tests that test that there's errors thrown and stuff like this, but for this case, we're just going to be testing this simple functionality. So the next thing we do is we create an instance of our smart contract by calling the constructor and passing the start time, the end time that we just created here. Now we have an instance of our smart contract which we can test. So I can describe the when deployed state. In other words, just after deployment, what should the behavior of this smart contract be? Well, it should not have started, right? Because, again, just coming back to this diagram here started is false because we're doing testing before the started state, and we haven't reached this point here yet. So we can make sure of that by writing these tests. And so what should we test? Well, we can use the expect notation, and we can say has started, and we can say to be false. All right, and let's run the test and see how that works. So I can run the command npm run test. By the way, how can I run that command? It's from here, scripts, and you can see here scripts. What this does is the test will basically run OZ, that's OpenZeppelin compile. That comes from the OpenZeppelin CLI. And then when that works, it will run Jest, which is the testing framework that I've chosen to use. And I'm a fan of Jest, so that's why I've installed Jest as a second dependency here. So as we can see down here, it's given us an error. Okay, and it's because we forgot the async. So let's go back to our test and put the async there and run the test again. This time it should be faster because it doesn't need to download anything or compile anything. It's just going to run the tests. And I put the async in the wrong place. So that should have gone right there. Okay, this time, third time lucky, we should see the test passing. And we do. So we can now see that when we deploy our contract, the has started is false. Okay, that's simple enough, right? But how about, okay, let's just quickly check the other state, which is that it should not have ended either, right? So let's just do that real quick here. We can say has ended also should be false, right? And npm run test. And we should see that also passing. And that really completes the after deployment tests, right? So that's the state here, testing before starting state. Now we want to do some time traveling. So let's get in our time machine. So the best place to put the time dependency stuff is in a before each loop. So, in a before each block. And what we want to do is wrap everything in a describe block as well. So let's have a describe block so that we know that we're about to move through time in this describe block. So we can say when enough time has elapsed to start the contract, Okay, so that's sort of a description on what we are wanting to do here. Then we have our before each block. And we need an async here because we're going to run an asynchronous method to move forward in time. So we await, and we use the time helper. And this time what we're going to use is the function increase2. Okay, increase2. And increase2 takes a parameter which is the time that we want to increase our block time to. And so where do we want to go to in time? Well, it makes sense to move the block time to the start time of our contract, which is the start time variable here. So if I put start time here like so, that's fine, but then this is in milliseconds. So it's going to give us the exact time for the start time of the contract. And we might want to go over a little bit just to be sure and to avoid maybe some potential bugs in our testing. So it depends on your logic, but I like to just, I just like to add just 1 second to that. So I just do add time duration seconds dot 1 second. So here I'm just saying, let's travel in time to the start time, but 1 second past that. And now we can actually just copy and paste these two tests. And by the way, you could have something like a behaves as function to avoid duplication in these cases, but I'm going to just copy and paste in this video, right? And what is the state now? Well, we know that it should have started because we've moved our time after the start time, so this should be true, but it still should not have ended because we haven't gone beyond the end time, all right? So what I'm going to do now is I'm going to use the handy watch switch on Jest down here, so that what happens is that Jest basically just watches for file changes and runs the tests whenever we make changes up here in our file suite. And so what we can do is we can just see the tests running down here as and when we make changes. So now we can see that the tests should be passing, so all are passing. So now we've got our tests for just after deployment, but before it started, the time has moved forward, and now the contract state is started. So it just leaves us with the end. So let's add another describe block. I'm going to just copy this one and put this here. And when enough time has elapsed to end the contract is what we want to test. And what do we want to do? Well, we want, again, a before each. So we just copy that. And this time we want to increase the time to the end time. So end time. And then we just add 1 second. So we can be absolutely certain that we're over the end time there. And then again, it's the same two tests, which, as mentioned before, these could be in a function which allows you to reuse your tests. And we should see here that the contract should still be in a started state. In our case, it's still started. However, it's now an ended state. And notice as I save that, it starts to run all the tests again. And that should be enough to test our time-dependent smart contract. Now, this is a very basic example, I know. As I've mentioned, you could have some of these in helper functions so that you don't have to copy and paste. You would probably be using this in the scenario of crowd sales, where you have things like open and closed for the crowd sale rather than started and ended, so that basically once a contract is closed, it's also no longer open, and those kind of conditions, right? And then there's also post crowd sale conditions that you might want to test as well. But really, this is just to help you get started, to make you aware of the OpenZeppelin time helper functions that are available, and to basically to check that out here on their OpenZeppelin documentation. So if you head over to their docs, you can have a look at the API reference. And if you scroll down to the bottom of this page, right way down to the bottom, you'll see the time helpers just here under the header time. And here are some of the functions that we've been using, like latest and increase to, and so on and so forth. So you can see there's different ways to increase time. There's different ways to look at get the blocks time and advance as well, and so on. So take a look at that. Have a look at how you can test your smart contracts using OpenZeppelin, and I'll see you in the next video. Please take care. Please do like this video if you do like it, and please subscribe, as I'll be making a lot more content going forward. Thank you very much, everyone. Take care. Bye-bye.